Welcome to another Build Day Live video here at Cohesity. I'm Alistair Cook, and I'm joined for this video by Anand Nadarthur. Anand, would you just tell us what it is that you do here at Cohesity?
Yeah, thank you so much for inviting me. My name is Anand Nadarthur, and I'm a Senior Director of Product Management for the Cohesity data platform and our scale-out NAS solutions.
What I thought we'd talk about was some of the considerations as customers are deploying the Cohesity platform and the things they need to think about around designing solutions. And you had some perspectives around having different types of workloads, virtual machines, and maybe native SQL and those kinds of things. What sort of design considerations should we be thinking about?
First, thank you for choosing our platform. And then once you have chosen the platform for use, you want to think about the different workloads that you put in. As you rightly said, you may have a thought of using the platform for converging all of your secondary workloads. That's kind of the prime purpose of what the Cohesity platform can offer. But as you think of workloads that require, say, better performance from a throughput perspective. For example, you want to do a SQL dump. As you start designing and implementing views and storage domains, which I will explain a little bit later, you want to think of choosing the right QoS policies for those, because they all require better performance from an ingest perspective, and then potentially the application is performing all the dedupe and data reduction capabilities. Go ahead.
Pardon the interruption, but I just wanted to frame that, of course, because we're consolidating multiple use cases into one place, then there's certainly issues where you get a noisy neighbor effect and you get low priority things demanding lots of resources and high priority things that are getting starved of resources. And this is why the quality of service becomes important.
Absolutely correct. The moment you put in the different QoS policies for each of the workloads, the underlying system ensures that each of the workloads get the appropriate throughput and so on and so forth, right? So as you create what we call views, think of views as a logical container for where your application is writing data to, or it is a container from where your data is being served to applications, right? Because we also support NFS, SMB, and S3 protocols, a multi-protocol environment. So you could be hosting the platform for sending out data. So if it is an NFS environment, you probably want performance for NFS workloads, which are typically, say, home directories, and you may have 10,000 active connections at any point in time.
But it's small IOs and it's
Yes.
blocks, it's file share storage, so lots and
files,
lots of parallel
exactly.
small IOs.
Small files. In a typical home directories, you will find a lot of small files. But at the same time, you can also think of having a view for, say, an archive workload, which could be potentially, should I say, large files. Think of a legal environment where a customer is putting a lot of scanned images, or a bank putting a lot of scanned checks, or a video surveillance where people put some kind of images onto it. They are all large files, but they require a different kind of performance.
Sequential write doesn't mix well with
doesn't
small
mix well with small, right? So along with all these, you're also going to find your backup sitting on the same place, because this is a hyper-converged environment. So you're going to see backup sitting along with these type of workloads. So this is where the next definition, as I called out earlier, storage domain comes into picture, which is a storage domain is a consolidation of the different views, right? So you could typically create more storage domains and have multiple views underneath that. You could have a set of policies for storage domain for, say, dedupe and compression, which says inline compression, inline dedupe. You could do all of those at the storage domain level, and at the same time, you can go back and overwrite it at a view level. So you have that flexibility.
So we've got a two-layer structure here where that storage group is allowing us to do one set of policies, and then the view lets us have another set of policies, and the storage group is a container for a group of views, as well as presumably for some physical storage underneath.
Yes, so it allows you to these are all at the logical layers.
Okay.
Right? These are all at the logical layers. So it allows you to have different levels of policies, and it allows you to do encryption. So it gives you the flexibility to choose what you want. So if you're a small organization, you're better off with just one storage domain and having multiple views. And you also have a construct of orgs in our product, which allows you to have, should I say, multiple tenants. So you can choose tenants and say, these tenants are fit for these storage domains, and these tenants fit in another set of storage domains.
So in-house, it may be that I've got a storage domain with strong encryption on it that fits to my financial component of my organization, and another environment that is no encryption because that's going to be less resources used for other workloads.
Yes. So I would say if you're thinking of putting multiple workloads, right, I would start with a fresh paper and pen and say, here is kind of what you want, right? And then that makes it very easier, because it's very easy to go and create a storage domain or a view with a few clicks, and then you will end up in the same spot as where you were before, which is oh, what did I do? So it will be best to organize what you want out of the system upfront, and then go and simply do it, because it's easy to create all these things. And the next thing you want to keep in mind is, how are you going to provide access to all these? So we also have a concept of RBAC. So you would have specific roles. So we have capabilities in the product, for example, locking. Locking requires special rights. So only people with those access privileges will be able to lock either a snapshot or either lock a given view. So we have 5-level locking. So you want to be clear on which users are going to get what kind of access permissions. That's another consideration I would put
in this context, locking means this particular point in time of the data is not going to be cleaned out, not going to be garbage collected out at a point. Am I getting the right term on the locking?
Yeah, kind of. Locking allows you to retain a view, retain a snapshot for a period of time. So if you have any legal commitments and say, I want to retain this particular view for 7 years. So you can retain it for 7 years. So once you set the policy for 7 years, you don't have the ability to go and delete it, right? So this allows us to be a right fit for a lot of companies which have all these legal requirements, compliance requirements, right? So that is another one that you want to be careful about. And the next one you pointed out was around the encryption. And then comes our native integration with the cloud, right? So this is something that is also set easily when you go into the storage domain and say all these can be easily archived off, and archived off to an S3 target, right? So the question now is, where do you want to archive them off? Because sometimes you want to arrange your data based on what goes to the cloud versus what doesn't go into the cloud. So that's another consideration I would have before I lay out my data on the system. If your SQL data is all going to be on-premise and you're never going to archive it off to the cloud, keep that in a separate set of storage
And again,
domains.
maybe that's driven by legal compliance that you must keep it on premises.
Yes, it fits in well into that structure as well. So that would be another constraint that I would put. Now, we have added the ability, or we always had the ability, to have both replication and archiving are all capable of being coexisting, in the sense that you could archive off to the cloud at the same time replicate it to another Cohesity cluster. So that consideration is always there. Do you want to replicate to some other secondary cluster from where you can restore things back in case something happens to this primary cluster? So that capability is always available. Instead of that being an afterthought, you can think of that as well. So that way you are going to the cloud and at the same time replicating to another cluster.
And I have another video recorded with Rawlinson, where we walk through how that data efficiency is maintained all the way through.
Yes. So this is one of the interesting parts about our platform is our efficiency is global in nature. And when we talk about global efficiency, we say it is across views, across all nodes within the cluster. And once you put things within orgs, you can say, my org should not be getting this efficiency from your org. So you can make that kind of a separation.
Yeah.
And at the same time, because of the underlying mechanics we have on our platform, whenever you're replicating to another site or archiving to another site, we check with the destination and say, hey, specifically for replication, we check with the other site and say, is this block already there with you? In which case, we don't even send the blocks out, which is quite different than some of the other technologies where it does the dedupe here, but then, yes, I have dedupe, but I'm still sending it there, right?
Do a rehydrated replication. Yep.
Exactly. There is a rehydration. And secondly, if both of us are replicating to a third site, you may have replicated the same block. I don't need to replicate that. Yes, you have deduped it. Even I have deduped it, but it still doesn't need to go there because you already sent a copy.
Because he's already deduped it.
Yes. So those kind of things are all taken care of as part of the platform, and you don't need to worry about multiple clusters sending on to the same site. And that is where I would pitch in our product Helios, which gives you a global view of the different clusters in your environment. And you can really see from Helios which sites are talking to which other sites, what are the different policies across the sites. Those kind of capabilities are always available. Right? And I'll finally touch upon one other aspect, which is our licensing. Our licensing is very simplified. So you get the product, you start to use it. We have 90 days of free trial for you to start using your product, and then you get what you want. And it's only after the 90th day that we say, hey, it's time for you to go enter the keys. But if you got the keys from us, and the keys are automatically installed from our Helios. So once you register with your cluster, based on the entitlements you have purchased, the keys get automatically sent over to your cluster behind the scenes.
So that's all centrally managed through Helios rather than distributed across all of your clusters.
The entire process is simplified. You don't have to remember a 16-digit key or a 26-digit key, whatever be the key length is. All those things happen behind the scenes for you. Our goal is to ensure that once you get the platform, you can start using it right away.
Well, thank you very much, Anand, for joining me today.
Appreciate it. Thank you so much for the opportunity to speak about product.
Thank you for joining us. Stay tuned for more great content from the Build Day Live event here at Cohesity.